So let's talk about a probability tree diagram. So the following example, I'm going to go ahead and just jump into it and read it out and we'll work on it. Bag A contains 10 marbles, of which 2 are red and 8 are black. Bag B contains 12 marbles, of which 4 are red and 8 are black. A ball is drawn at random from each bag, and we want to find the probability that A, both are red, B, both are black, C, one is black and then one is red, and then D, at least that one of them is red. So the first thing that we're going to do for this example is we're actually going to draw out the tree diagram. So our starting point here, okay, bag A is what we're going to deal with first. And in bag A, we have 10 total marbles. 2 of them are red, 8 of them are black. So I'm going to call this one red and this one black here. So if we have 10 total marbles and 2 are red, that means 2 out of the 10 marbles are red. This actually simplifies to a 1/5 when we divide both of it out to 2. So the probability of getting red on your first draw here is going, or from your first bag, is going to be 1/5. So for the black, we have 8 total black marbles out of 10 total marbles in all. Right, so that's 8 out of 10. This simplifies to 4/5. So that means you have a 4/5 chance of drawing a black marble from that first bag. Next, what we're going to do here is we are going to branch out, and let's just say, okay, so we chose one from bag A, and let's say we chose red from bag A. Now we're going to pick from bag B. So if we got red on bag B, on bag A, what's going to now happen with bag B? If we take a look at bag B has a total of 12 marbles. So 12 is our total for that. We have 4 red, and we have 8 black. So let's simplify that here, because our choices are going to be red, black, and then red, black. So let me go ahead and draw that out here. So if we have the probability of getting a red is 4 out of 12, if we simplify that by dividing out the 4, we actually get a 1/3. So we have a 1/3 chance of getting a red. And that's going to be a 1/3 chance whether we drew a red the first time, black the second time. Doesn't matter. With the second bag, we still have a 1/3 chance of getting a red. So that 1/3 is going to go for both of the reds there. Now for black, we have 8 out of 12. And 8 out of 12 is going to simplify here. So let's see, if we reduce this, we get a 2/3 chance of getting a black. And again, that's going to be for both of them. Okay? So this is our probability tree diagram. So for bag A, it's a 1/5 chance of getting red, 4 or 5 chance of getting black. Bag B, it's 1/3 chance of getting red, 2/3 chance of getting black for that one. So let's take a look and see if this can help us answer the following questions. So when it comes to doing these calculations, it's essentially a lot of multiplication. You're going to multiply the probability of the first instance times the probability of the second instance. So this is how it works. For example, A, we want to find the probability that both of them are red. So on bag A, we choose a red, bag B, we choose a red. So if we take a look at the chance of getting probability of red from bag A, that is a 1/5. And we are going to multiply that times the probability of getting red from bag B. And if we look at bag B, our probability of getting red is a 1/3. So we are going to take the 1/5 chance of getting red on bag A times the 1/3 chance of getting red for bag B is going to give us a total of a 1/15th chance of getting a red and then a red is how that works. So for example, A, it is a 1 out of 15 chance of both of them being red. So we go to our red branch and we take that number and we're going to multiply that times our red branch over here on bag B. Example B says, what is the probability of both of them being black? So that is going to be very similar to what we just did. So if we start back at the beginning of the tree, the probability of getting black is 4/5. And then we're going to multiply that by the probability of getting black on the second bag, which is going to be 2/3. So we go 4/5 to black, and then 2/3 over here black once again. 4/5 times 2/3, remember fraction multiplication is straight across. 4 times 2 is an 8, 5 times 3 is a 15. So we actually have an 8 in 15 chance of getting both black, so much higher chances of that happening. For example C, we are looking at what is the probability of getting one black and then one red. So we're going to do black and then we're going to do red. So we're going to start with our black branch over here. So the probability of getting black is 4/5. And then after that we want to go red. So we want to go up here to red, which is 1/3. 4/5 times 1/3 is going to give us 4/15. So the last question asks, what is the probability of at least getting one red? So I want you to take a look at something real quick. So when it comes to this problem, there's really 4 options. We can take this branch, red, and then we can go red. So we can do red, red as an option. The second option is to go red and then go black as a second possibility. If we go black first, we can go black and then we can go red. Or we can go black and then we can go black. Right, those are our only possibilities. Red, 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 black, black, red, black, black. Okay. Now D says, what is the probability of at least one of them being red? So I want you to take a look at these options here. This one has red, red. So if we did this option, we're definitely getting a red. The second one is red, black. Well, one of those is at least red. So if this happens, we're still getting red, which is fine. Third option here, we could go black and then red. There's still a red in there, so that's good. The only possibility where we would not get a red is if we went black, black. Okay, so what we're going to do here, so remember that probability is out of a total of 1. So 1 is saying it's a 100% chance of that happening, where the closer it is to 0 is absolutely 0 chance of it happening. So considering that 3 out of our 4 options contain a red, instead of calculating the probability of all 3 of those happening, it's actually easier to calculate the probability of getting black, black, and then just subtracting that from 1. Because remember, 1 is a 100% chance of it happening, but if we take that and just minus out the black, we're going to be left with the probability of the rest of them happening. So we really want to do 1 minus the probability of getting a black, black. Now, the probability of getting black, black, so first bag, bag A, we have a 4/5 chance in getting black. And then on our second bag, bag B, we have a 2/3 chance of getting black. So if we calculate that, that's actually an 8/15 chance of getting black. So if we have an 8/15 chance of getting black, if we subtract that from our total probability of 1, it's going to leave us with a probability of getting red. So if we take 1 minus 8/15, we're actually going to get, that's going to leave us with 7/15 when we do that subtraction. And if you want, you can go ahead and carry out that subtraction on your own, but you will get 7/15. So just do the chance of getting black, subtract that from 1, and that's going to give you the chance of getting red. Otherwise, that's it for this video.